Lab 4 Territorial and Sexual Behaviors of Crickets. In this lab, our purpose was to explore the territorial and sexual behaviors of crickets and their preference of habitat. The species used in this lab was house cricket. There is strong sexual dimorphism between females and males. Females have long ovipositors for egg laying, and only males have song which produced by apparatus in the wing. Male crickets are territorial, which means they will defend their territories against other male crickets. In our lab, we used the 5 levels of aggression determined by Alexander and Simons, which range from 1, the lowest level, to 5, the highest. Also, males have courting behaviors towards females. Overall, in our group, the male crickets had territorial and courting behaviors, and both male and female crickets liked soil best. We have 2 hypotheses. The first one is that the male crickets would establish a territory in a few days and defend it, and they will perform courting behaviors to the females. The second one is that both the male and female crickets will like the soil most as their habitat. All of the materials and methods can be referred to Lab 4 handouts as described. There is only one change, that males were labeled green, pink, and yellow, while females were labeled green and white. In our lab, there are 2 parts. The first part is cricket territorial and mating behavior, consisting of 6 small experiments. In the first experiment, we added 1 female labeled green into the box containing 1 resident male. We predicted that after mating the female cricket, the male cricket will perform courting behavior to the female cricket. In Figure 1, male followed female. In Figure 2, male stroked female on antenna and sun. In Figure 3, male sang and sometimes guarded the female. In this experiment, the male cricket performed courting behaviors like antenna stroking, chirping, following, and guarding to attract females, which supports our hypothesis and prediction. So we concluded that male crickets will perform courting behaviors to females. In the second experiment, we added another male cricket labeled pink into the box. The prediction is that 2 male crickets will perform courting behavior to the female, then fight against each other. In Figure 4, the resident male followed the invading male and touched him. The aggression level ranged from 1 to 2, which means there were only mild interactions between them. In Figure 5, the invading male performed courting behavior, and the resident male guarded the female by chirping and flattering wings. In Figure 3, the invading male stayed away from the other 2 crickets. In this experiment, both males pursued the female, and the resident male defended his territory and guarded the female. So we concluded, according to Figure 4, 5, and 6, the dominant male crickets will demonstrate territory, defend its territory, and guard the female crickets by body touching, chirping, and wing flapping. In the third experiment, we added another female labeled white and another male labeled yellow into the box. We predicted that all males will perform courting behavior to the females, and the resident male cricket will defend its territory and guard the female. In Figure 7, the resident male followed the invading males and touched them on antennas. The aggression level was still ranged from level 1 to 2. In Figure 8, the invading male stroked females on antennas, and then the resident male guarded the female by chirping and flattering wings. In Figure 9, the 2 invading males stayed away from the female, which was pursued by the resident cricket. In this experiment, all the males pursued the females, and the resident male defended its territory and guarded the female crickets. Figure 7 and 8 supports the conclusions of territorial and courting behavior stated before, and according to Figure 7 and 9, adding female crickets increased the level of and times of aggression between males. Here, Figure 9 and 6 specifically proves that although the male crickets always defended its territory successfully, there wasn't always a fight between them. If the exotic males do not intend to compete with the dominant male for the living area of female crickets, there will not be aggressive conflicts between them. Generally, the songs of males are used to attract females according to Figure 2, 3, and 7, and warn other males according to Figure 5 and 8.
The next experiment was one with two male crickets, the resident male that had established his territory and a foreign cricket labeled yellow. Figure 10 is a photograph from this part of the experiment. You can see the resident male in the upper left-hand corner and the yellow male on the right. Immediately, these two males were aggressive towards each other, climbing on top of one another and demonstrating their dominance. The resident cricket seemed to emerge as dominant, finishing the encounter with some wing chirping before the two males separated and avoided each other entirely. The chirping seemed to be directly related to the aggression. The next experiment was one with two males and one female. The males immediately took their attention off one another and began courting the female, following her and chirping for her in a mating attempt. The males ignored each other entirely. The last experiment included 5 crickets, 3 male and 2 female. The most dominant males, the resident cricket and yellow one, seemed to pick favorites with the 2 females and guarded one almost exclusively. The third male was significantly smaller than the other 2 and spent most of the experiment by himself on the side. There was some aggressive behavior between the males, but most of the attention and effort went to chirping for the females and following them throughout the terrarium. Our hypothesis was that the male crickets will establish a territory in a few days and defend it, and they will perform courting behaviors to the females entering their territory, and this is supported by our observations. To wit, the male cricket resident to the terrarium was territorial in both cases, but more so when only with a male. Aggressive behavior included climbing on one another and chirping. The yellow male backed down, so the territorial male won out. The crickets do not always fight. More often they would examine one another, then avoid and scatter. When more crickets were added, the territorial male chirped more often, but usually when near a female. This may or may not be related to defending his territory. The second part of this lab was an experiment to see which of 4 substrates a cricket will prefer: soil, sand, rock, or no substrate at all, just a cage bottom. Figure 11 is a photograph of our setup, the terrarium where the experiment occurred. The crickets were timed in seconds and the time was recorded as our data. Figure 12 is a graphic representation of the data we obtained from our 3 female crickets and 3 male crickets that were tested. It can be very easily seen that the females preferred the soil above all other substrates in this experiment, but the males seemed to be more evenly distributed. The class I was averaged together to get an average time in seconds that the gender spent on each substrate. Table 1 contained the number of these means. It seems just by looking at the numbers that the males are much more spread out than the females. The males spend 317 seconds on the soil and 207 seconds on the sand on average, where the females spend 466 seconds on the soil and very little anywhere else. It should be noted that that many in the groups in this experiment observed that there was an egg-laying behavior in the females. When they were released into the terrarium, they sought out the soil and began digging down into it, then turned and inserted their abdomen into the soil. This took a few minutes. Figure 13 is a graphic representation of the data in Table 1. It can be easily seen here that the females did spend much more time on the soil than they did anywhere else. The males spent most of the time on the soil as well, but they are much more evenly distributed between the substrates than the females are. Analysis of variance, or ANOVA, is a series of statistical tests one used on sets of data to show if the data is significantly different from another set. It tests the null hypothesis that there was no change whatsoever. If the p-value is under 0.01, the null hypothesis should be rejected and there was a change in the data. Table 2 lists the p-values for our data. It compares the sand, soil, rock, and cage bottom times of the males to that of the females to see if they behave significantly differently from each other. All these numbers are above 0.01, so there was no significant difference in our data. Here in Table 3 are the class data ANOVA results. These are done slightly more extensively because there's much more data to work with. Table 3 lists the ANOVA results when the data of the male and the female crickets were compared to themselves, not to each other. The male soil and sand times were tested, sand and rock, rock and cage, etc. The same were done for the females. Many of these are significantly different. For the males, the soil versus sand, soil versus rock, and soil versus cage were under 0.01. For the females, soil was statistically different from all 3 of the other environments, and sand was different from rock and cage bottom. Finally, Table 4 lists the p-values when the substrates were compared between genders. The soil results for the males and females are statistically different, and so are the results for the rocks. This means that the results seen in Figure 13 can be trusted to be significant. The females preferred the soil above all other substrates, which may be linked to the egg-laying behavior that was observed during the experiment. The males also preferred the soil, but not nearly as much as the females did. The males tended to wander throughout the terrarium, while the females found a spot they liked on the soil and stayed there to dig. And this is our authorship and sources, and thank you for listening.